Hi guys, it's Miss Griffin. We're taking a look at Unit 5, Skill 2A. What steps are important in solving quadratics by factoring? So this should be pretty much a review for you about factoring completely with a GCF, add, multiply, tricky tries, and DOPS. And then next skill, we'll get into quadratic formula. So first, let's write out some important steps off to the side. Whenever you're solving quadratics, you first need to get it equal to 0. With the x squared term positive. This could also be talking about any term that's higher than x squared, meaning like x to the third or higher too. You want that to be positive. Whichever is your highest term needs to be positive. We'll talk about why in just a minute. So then step 2 would be to factor. That's where you do like the parentheses, equals 0, blah, blah, blah. Step 3, if I can move this up, is to set each factor equal to 0 and solve for x. So we'll take a look at this first equation. We've got factoring completely with GCF and add multiply. This comes from skills 1.3 and 1.6, so I'm going to go through this kind of quickly. 4x squared minus 32 equals 28x. So clearly x squared is my biggest term. It is currently already positive, and therefore I want to take the 28x, bring it to the other side. So I'm going to have to do that by subtraction, meaning I have 4x squared minus 28x minus 32 equals 0. Then my next step is to always look for a GCF, see if there's something in common. I notice that I have a coefficient of 4, negative 28, and negative 32, meaning I can divide every term by 4. So my GCF stays out in front, still equal to 0. Whatever was left over from that division goes inside the first pair of parentheses, the one and only pair of parentheses. These cancel, so I have x squared. This gives me minus 7x and minus 8. From here, my GCF stays out in front, and then 2 pairs of parentheses, because now this can be factored by add, multiply. So I'm coming up with number pairs that multiply to 8, like 1 and 8, 2 and 4. And I need a pair that helps me add to negative 7, so clearly that's going to be the 1 and 8. So x in the first spot of both to make that x squared term, 1 and 8, and bigger number takes the sign of the middle term. So that means I have a minus here and a plus here. Now this is step 3, T-chart, set each factor equal to 0. So I have 4 equals 0, but that's not a true statement, so I cross it off. I have x plus 1 equals to 0. To solve for x, I have to subtract 1, so x equals negative 1. And x minus 8 equals 0, so in this case x equals 8. There is a quick trick for this part when it's just simple one-step equations. So we have x plus 1 obviously turns into x equals negative 1. X minus 8 turns into x equals 8. Okay, so that was the first one. The next one, very similar, except we want the highest term positive. Currently the highest term here has a exponent of 3, which means it's on the wrong side because it's a negative right now. So I want to bring this stuff to the right. So then I would have 0 equals x to the third minus 3x squared minus 4x. And again, I want to look for a GCF, see if there's something in common. This time it's not a number. This time it's a variable. So I have 0 equals x parentheses, because I'm going to divide every term by x. So now we get x squared minus 3x minus 4. And again, still equal to 0. It doesn't matter if the 0 is on the left or the right, it's your choice. So now I have x parentheses, parentheses. you should be able to pause this video and fill in the rest from here. So I have x minus 4 and x plus 1, and then with the t-chart I get x equals 0 here. Remember, set each factor equal to 0, or if you know the trick, just solve it right away. X equals 4 and x equals negative 1. So this one has 3 solutions. It was x to the third power, meaning there should be 3 solutions. It's a polynomial that crosses the x-axis 3 times. Next we have factoring by DOPS. DOPS, again, we've told you guys this several times. DOPS stands for difference of perfect squares. And so the difference means subtraction, perfect squares means you can square root them very easily, and you get a whole number. So when I see n squared, which is perfect, I can take the square root of it. Same thing with the 16, I can take the square root of it. So I know that this can factor into 2 pairs of parentheses, n and n, because that makes the n squared, 4 and 4 to make the 16, minus and plus to make that difference if I were to double distribute this back out. And then of course n equals 4, n equals negative 4. The next one's very similar, except I have to get it equal to 0 first, with the highest term positive. So 9x squared is going to stay right where it is. Subtract the 49 equals 0. And again, I'm going to factor into 2 pairs of parentheses because there is no GCF. 9 does not divide into 49, nor does 3, etc. So to make 9x squared, I have to have 3xx, right? 3x times 3x makes 9x squared. To make that 49, I have to be thinking about 7s, because again, I'm just square rooting these terms. Square root of 9x squared is 3x. Square root of 49 is 7. Plus and minus, then t-chart. This is where it gets a little tricky, which is why you want to make sure that you know that essentially each factor is getting set equal to 0. Because I can't just say, oh, x equals negative 7, because it's false since there's that 3 in front of it. So I subtract 7, 3x equals negative 7, then I divide by 3 and I have x equals negative 7/3. Same idea over here, 3x minus 7 equals 0. Add the 7, so 3x equals positive 7 this time. And now x equals 7/3. That's a really wonky looking 3. That's a 3 for sure. Okay, these are your 2 solutions. Flip it over and we will see a couple other examples. So with example 5 back here, we are looking at some tricky tries. And this is your guess and check stuff. So again, first we still have to get it equal to 0. So I'm going to add the 3x to the other side. So I have 10x squared plus 3x minus 18 equals 0. And you want to be thinking, well, first, is there a GCF? And I don't see one. 10, 3, and 18 have nothing in common besides 1, and taking out a 1 wouldn't help. And so I'm looking and I'm like, okay, how can I make a 10? Because I know I'm going to have 2 pairs of parentheses equal to 0. I know to make the x squared, I definitely have x and x, but somehow here and here I have to make 10, right? So that could be 1 and 10, or it could be 2 and 5. So when I do this, I always set this up as 2 options, where, let me just erase this, where I say, okay, one option is 1x, 10x, are going to equal to 0, and then the other option is 2x, 5x. I set up all the possible cases, so then that way I can figure out, okay, well, the 1x, 10x didn't work, so now I need to try the 2x, 5x. Okay, so then we're thinking about add, multiply. So remember how you make your factor list of 18? Well, you can do it right here off to the side, wherever you have space, but you definitely want to write them down. You have 1 and 18, 2 and 9, 3 and 6. So now here comes the guess and check. We've already done the 1 10 to 5 part. Now we need to deal with these purple numbers, 1 and 18. So if I were to think about putting 1 here and 18 here, I need to see if these terms, when I multiply them, would add up to 3. And it's a positive 3. So I would get a 10x out of this and an 18x out of this, right? 1 times 10, 1 times 18. Those will never help me to add to 3, so I'm going to erase. That didn't work, so now I'm going to switch their spots. 18 and 1. Whoa, this would be 180. No way am I ever going to get 3 out of 180 and a 1, right? So I'm going to erase them, and I'm going to just put a check mark or cross them off, showing that I've tried it. Then I tried 2 and 10, or 2 and 9. 2, 9. This here gives me 20. This upside down smiley, or upside down rainbow or smiley face gives me 9. 20 and 9. Those won't help me. But if I erase them, switch their spots. Try again. 9 and 2. Wow, that's 90 and 2. Nope, not going to work. Okay, so I've tried 9 and 2. Put a check mark to show that I've tried it. 3 and 6. Well, think about it logically. If I put the 6 here, it would give me 60 and 3. That won't work. If I put the 3 here, that gives me 30 and 6. That won't work. So I've tried 3 and 6 here. Now let's start trying some things down here at the bottom. At the 2x and 5x, because clearly this one didn't work out for us. Okay, so now we're guessing and checking again. I'm going to start with the 3 and 6. I'm going to start from the bottom of the list this time. It could be a good choice. It could be a poor choice. I have no idea. So I'm going to try 3 here, 6 here. This smiley gives me 15x. This smiley gives me 12x. Holy moly, we might have found it. Remember, we're trying to add to a positive 3. And so I'm thinking, okay, well, I'm multiplying to a negative, so I know one of these numbers has to be negative. But then the other one has to be positive. I want a positive 15 and a negative 12. Meaning that this loop has to have a positive 3, this one has to have a minus 6 in order for this to be a negative 12x. So I'm going to take this off to the side here. I've found the next step to my answer. But remember it says solve, so we're not done. We've got a t-chart, set each factor equal to 0, and then solve. So this one we would have x equals negative 3/2. And x equals 6/5. We've always left you guys at the step of just factoring this into the 2 parentheses, but now we want you to solve these tricky tries because it's no different than solving any other quadratic. And then we've got this other example, last one, 3x squared equals negative 4 plus 13x. Again, get it equal to 0 where your x squared term is positive, so this step on the right needs to move left. So we have 3x squared plus 13x plus 4 equals 0. And I just lied to you. This is actually a minus 13x because remember we're moving it over by doing the opposite. Minus 13x plus 4, so on and so forth. So again, I look at my numbers. I see 3, negative 13, 4. Nothing in common. So now I've got to think, okay, well, how am I going to make 3? Lucky for you, it's only 1 and 3. How am I going to make 4? 1 and 4, 2 and 2. And again, we have to add to negative 13, multiply to 4. So you should be setting up your parentheses, 1x, 3x equals 0. And now you are going to guess and check with these 1, 4, 2, 2 to figure out how you can add to negative 13. Hit play when you're ready to see the results. Alright, so I've got x minus 4 and 3x minus 1. And then final answers should be x equals 4 and x equals 1/3. Let us know if you have questions, but again, this is just review of what we've been working on in Unit 1, factoring using different methods. Adios.